to my channel today. Today we'll be treating number bases. We'll be starting with conversion of a given base to base 10. Now we are given three questions here. They say we should convert the following to base 10. And another name for base 10 is denary. It's the same thing as what? Base 10. While binary is another name for base 2. Now moving further, solutions. Number 1, we have 2120 in base 3 is equals to. Now converting this number to base 10, what we have to do is use all these numbers and multiply this 3 here, which is the base number. We have 2 times 3 raised to power. What you have to do for you to know the power of this 3, depending on the number, is remove this particular 2 here. After removing 2, count the remaining number. The number of this remaining number will be your power 3 here. It will be the power of 3 here, which is what? If you remove this first number, the first 2 here, we use to multiply this 3, and you count 1, 2, 3. Therefore, the remaining numbers here, the numbers here is what? 3. This will give us 2 times 3 raised to power 3. Plus, you can put them in bracket. The second number here is 1. Open bracket. 1 times 3 raised to power what? Now you remove this 1 here, count the remaining numbers at the back of 1, which is what? 1, 2. Therefore, the power of 3 here should be 2. You write to 2, close bracket, plus the next one is 2. You open your bracket, you have 2 times 3 raised to power. The remaining number at the back of these 2 here is just one number, one digit. You have your 3 raised to power 1 bracket plus open bracket. The last digit here is 0. You write 0 times 3. How many numbers is at the back of this 0? None. Therefore, it should be what? 0 times 3 raised to power 0 is equals to, now simplifying, you have what? This bracket 2 times 3 raised to power 3, the same thing as 3 times 3 times 3 into 3, which will give us 3 times 3 times 3. Now 3 times 3 here will give us 9. Have your 9 here. 9 times 3 here will give us 27. Therefore, we have our 2 times 27 bracket, close bracket, plus open bracket, 1 times 3 raised to power 2 is 3 times 3, which will give us 9. Have your 9 here, close bracket, plus 3 raised to power 1 is the same thing as 3. Have 2 times 3 bracket, plus open bracket, 0 times 3 raised to power 0. We know that any number raised to power 0 will give us what? 1. Is one of the laws of indices. Now this 3 raised to power 0 is automatically 1. We have what? 0 times 1 bracket. This will give us equals to, now 2 times 27 here will give us 27 multiplied by 2 here. This will give us 2 times 7 will give us 40. Write 4, carry 1. 2 times 2, 4, plus 1, 5. We have 54. 54 plus 1 times 9 here will give us 9, plus 2 times 3 here will give us 6, plus 0 times 1 here will give us 0. Now we add up. 54 plus 9 here will give us 63. Have your 63. 63 plus 6 will give us 69. And 69 plus 0 here will still give us 69, which is in base 10. Therefore, our final answer here is 69 for question number 1. Now, we're moving over to question number 2, which is in base 2. We are asked to convert it to base 10. number 2, we have 11001101 in base 2. Now, what are we going to do? We start with the first digit, which is 1. 1 bracket, you can put it in bracket, times 2 raised to power. Now, for us to know the power of 2 here, we have to remove this 1 and count these numbers at the back of this 1 that's multiplying these 2 here. To know the numbers of digits here, we have what? 1, 2, 3, 4, 5, 6, 7. Therefore, this 2 is 2 raised to power 7. Close bracket plus the second digit here is 1. You open your bracket again, write 1 times 2 raised to power. You count the number of digits at the back of this 1 here, there should be 6. Write your 6 bracket plus the next number here is 0. Have your 0 times 2 raised to power. Count the number of digits that are here, which will be 5 raised to power 5 plus the next number here is 0 again. Have your 0 times 2 raised to power 4 plus the next number here, we have 1. 1 times 2 raised to power 3, close bracket, plus the next number is 1 again, bracket, 1 times 2 raised to power 2, close bracket, plus the next one is 0. 0 times 2 raised to power 1 plus, and the last digit here is what? 1. We have 1 times 2 raised to power 0. Now, moving further, you have your equality sign. We have 1 times 2 raised to power 7. Here we give us 2 times 2 times 2 times 2 times 2 times 2 times 2 into 7 times 1, 2, 3, 4, 5, 6, 7. Exactly. Now we have 2 times 2 here will give us 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2 will give us 128. Therefore, our answer here, 2 raised to power 7 will give us 128. Bracket 1 times 128, close bracket, plus open bracket, 1 times 2 raised to power 6 here should be 64. We have our 64 bracket plus open bracket, 0 times 2 raised to power 5. 2 raised to power 5 here should be 32. You write your 32. 32, close bracket, plus open bracket, 0 times 2 raised to power 4 here should be 16, plus bracket, 1 times 2 raised to power 3 here is 8, plus 1 times 2 raised to power 2 here is 4, plus, we clean this one so that we see more space. 2 raised to power 2 here is 4, plus bracket, 0 times 2 raised to power 2 here is descending as 2 raised to power 1 is descending as 2. Have your 2, close bracket, plus open bracket. Remember what I told you, any number raised to power 0 is descending as 1 is automatically 1, one of the laws of indices. You have your 1 times 2 raised to power 0 is 1 already. You have your 1 bracket. Now going further here, we have our is equals to 1 times 128 will still give us 128, plus 1 times 64 will still give us 64, plus 0 times 32 will still give us 0, plus the next one is 0 times 16, 0, plus 1 times 8, 8, plus 1 times 4, have your 4, plus 2 times 0, 2 times 2, 0 times 2, have your 0, plus 1 times 1 here will give us 1. This will give us equals to, we add 128 plus 60 plus 64 here will give us 192. Let me check it. 128 plus 64. Here we give us this plus this give us 12. You write 2, carry 1, add it to here. We have your 9, 1. Now we have our 192. 192 plus 8 here we give us 200. And 200 plus 4 here we give us 204. 204 plus 1 here we give us 205. You have 205 in base 10. This is our final answer for question number 2. Now moving further to question number 3, where we have what? Decimal point. Now question number 3. Now moving further to question number 3, where we have a decimal point. What are we going to do? You have your 3. Number 3, we have 101.0112 is equals to. Here, the first number we have here is 1. You have your open bracket 1 times 2. Now, raised to power. Why writing the power of these 2? Because of the decimal points. Don't count in all these numbers after the decimal point. Stop at the last number, the last digit before the decimal point, while counting for the power of what? 2. Therefore, counting here, if you remove this number here, this first digit we are multiplying with, you count 1, 2. So don't count in all these digits. Now what we are going to have here is 1 times 2 raised to power 2 plus open bracket 0 times 2 raised to power. We have only 1 at the back of this 0. 2 raised to power 1 bracket plus, now this next number is 1 open brackets 1 times 2 raised to power 0. Now plus, moving over to the ones that after the decimal point, what we have to do is have your bracket 0 times 2 raised to power minus 1. Immediately after the decimal point, you start adding what? Minus to the power of whatever base you have. Therefore, this first one here, you have your what? 0 times 2 raised to power minus 1. You have about 1. The second one plus, open bracket, the second number here is 1. 1 times 2 raised to power minus 2, which is about 2. Close bracket plus, open bracket 1 times 2 raised to power minus 3. Close bracket. Now simplifying further, we have our bracket 1 times 2 raised to power 2 will give us 4. This is 2 times 2 plus 0 times 2 raised to power 1 will give us 2 plus bracket 1 times 2 raised to power 0, 1 plus bracket 0 times 2 raised to power bar 1 is 1 over. Remember, bar is what? Over. We have 1 over 2 times bracket 1 times 2 raised to power bar 2 will give us 1 over 2 raised to power 2. Remember, bar here signifies over, 1 over. Bar signifies 1 over. Now we have, just like this, what we have here. This 1 over here is what? Is the bar. Then this 2 here is supposed to be 2 raised to power 1. I did not put the 1 because 2 raised to power 1 is the same thing as 2. But if you like, I can still put the 1. Now close your brackets plus, the next one here is 1 times 1 over 2 raised to power 3. Bar signifies 1 over. Then whatever you have next. Now, 1 times 4 here will give us 4. Plus 0 times 2, 0. Plus 1 times 1 here will give us 1. Plus 0 times half will still give us 0. Plus 1 times this will give us 1 over 4. Plus 1 times this, 2 raised to power 3 is equals to 8, which is 2 times 2 times 2. Since here 2 times 2 times 2. 2 times 2 here will give us 4. 4 times 2 here will give us 8. Therefore, this 1 over 2 raised to power 3 will give us 1 over 8 is equals to. Now, we add. This plus this will give us 5. Now, 5 plus 1 over 4 plus 1 over 8. You can use your calculator and change it to decimal fraction if you want. I will still do that later. Now we have the LCM here is 8. 1 divide 8 here will give us 8. 8 times 5 will give us 40. Have your 40. 4 divide 8 here will give us 2. 2 times 1 here will give us 2. 8 divide itself will give us 1. 1 times 1 here will give us 1. Therefore, what we are going to have here is 40 plus 2 plus 3 here will give us 43 over 8. Changing it to decimal fraction. Let me use the calculator. Now we have 43. Here we're going to get 5.375 in base 10 as the final answer. Now this is the final answer for question number 3. Just know that immediately after your decimal point, whatever power these two will be raised to will be what? Bar. Starting from 1. This one, bar 1. The first digit after the decimal point, the base will be raised to bar 1. The second digit after the decimal point, the base will be raised to bar 2, and so on. Now, we're moving over to the next topic. Conversion from base 10 to others. We have already treated from other bases to base 10. Now, we'll be solving from base 10 to others. All these numbers here are given in base 10. Now, solutions. The first number here. First question, they say convert the decimal number 89 to binary. Remember what I told you, that binary is descending as base 2, and this decimal number is descending as base 10. Now we are given 89 and we are asked to convert it to binary numbers. Now we have what you have to do is to draw something like a table, a line, a vertical line. Have your 89. Because they asked us to convert it to binary number, we'll be dividing this 89, which is in base 10, with what? By 2. You divide by 2, you have your 2 here. 2 divide 8 will give us 4. 2 divide 9 will give us 4. Remainder 1. Then remainder 1, just write R. That will represent the remainder. You write your what? 1. The second one, moving over, we have 2. 2 divide 4 here will give us what? 2. 2 divide 4 again, we have what? 2. There's no remainder. Remainder, just take that remainder. Once there's no remainder, take it as what? Remainder 0. 2 divide 22 here will give us 11. No remainder, have a remainder 0. 2 divide 11 will give us 5. Remainder 1. 2 divide 5 will give us 2. Remainder 1. 2 divide itself will give us 1. Remainder 0. 2 divide 1 can go. You have your what? 0. Remainder, that this number here, which is the last, going to the last digit, will be the remainder. Remainder 1, because 2 divide 1 can go, because 2 is bigger than 1. Therefore, you write to 0. That one should be the remainder. Now, this is how we are going to pick the numbers. Draw an arrow that is facing up. This shows that we have to pick the number starting with the what? The last digit. Now, this 89 in base 2 here, in binary number, will give us 1 0 1 1 0 0 1 in base 2. This is our final answer for question number 1. Now we'll be moving over to question number 2. Question number 2. They say we should convert 256 to base 5. Since they are asking us to convert it to base 5, here the second one will be dividing by 5, no longer 2. The reason why we divided by 2 in the first one is because they are asking us to convert it to binary number. Here is what? Base 5, no longer binary number. Now we have our 256. We have our 5 this side. Now we go 5 divide 25. Here we give us 5. 5 divide 6 will give us 1. Remainder 1. Write your remainder. That's one letter R. I can use capital any of them. Remainder 1. 5 divide 51. Here we give us 5 divide 51 will give us 10. 10 remainder 1. 5 divide 10 will give us 2. No remainder, therefore the remainder will be 0. Remainder 0. 5 divide 2, it can't go because 5 is bigger than 2. Write 0. Remainder, this 2. Now, this 256 in base 10 will be equals to, remember your arrow. You start picking from the last digit accordingly to the what? To the top. You have your 2011 in base 5. This is our final answer for question number 2. Now question number 3. Question number 3. This question number 3, they say we should convert 39 to base 3. Here we'll be dividing by 3, no longer 5, neither 2. Now we'll be dividing by 3 because they are asking us to convert it to base 3. You have your, draw your vertical line, have your 39, you have your 3 here. 3 divide itself, here we give us 1. 3 divide 9, here we give us 3. Remainder 0. Because there's no remainder. Once there's no remainder, the remainder is always what? 0. Have your 3 here. 3 divide 13 will give us 4. Remainder 1. 3 divide 4 will give us 1. Remainder 1. 3 divide 3, it can't go. You write, you have what? 0. Remainder, this one here. You bring it. You draw your arrow. You have your 39 in base 10 is equals to, start picking from the here, from the last digits here, is equals to 1110 base in base 3. This is our final answer for question number 3.